Hi everybody, let's continue to the telecom series. Now today we are going to discuss wireless communication, RF propagation, LOS and basics of antenna. So now let's discuss about some characteristic of optical fiber. Now if we talk about the attenuation, which means reduction of signal strength, which means after every kilometer how much strength goes down. So 1550 nanometer fibers always have lower attenuation, which is zero point 0.2 dB per kilometer. Now if we talk about the dispersion, which means broadening of the pulse, and for this 1310 nanometer single mode fiber has least dispersion. And if we talk about the multi-mode diameter, which is geometrical distribution of light in the core. So for multi-mode fiber, it is almost same as core dia, but it is critical for single mode fiber. So this shows which type of communication for which application you have to use which type of fiber with which optical window. Joining of two fibers are called splicing and connectorization. So let's start wireless communication. In wireless communication, basically radio frequency wave propagate in the air. So there is a classification. So for medium frequency, ground wave or surface wave are used. For high frequency, sky wave frequency reflected by ionosphere is used. And for VHF, UHF and microwave, LOS is there, which is line of sight or direct wave, ground wave, reflected wave, scattered wave or diffracted wave. So let's start discussing RF wave propagation, LOS, that is line of sight. In this, the main idea is that both TX and RX must be same line of sight, must be look at each other. Not mean physically looking at each other, it's mean on the curvature of Earth. Next slide will give you the better understanding. In this, generally what happen, baseband signal is there, which is modulated by carrier and passed to the passband, and the wireless RF or microwave transmission takes place as shown in the figure. And similarly at the receiver side, RX demultiplexer is there and signal is recovered. Just a basic idea for wireless channel communication. So here let's see the LOS and NOS concept. In LOS concept, line of sight range limited by the earth curvature and antenna tower height. They are both looking at each other and the wave is propagating. And in case of non-line of sight, the wave from TX to RX going either by reflected way or diffracted way or scattered path, which means multiple paths are there for non-line of sight. So let's discuss about antenna basic. Basically, antenna act as a circuit device and space device. Why? Because it has to carry the signal first, then radiate the signal into the air. So basically, radio antenna is defined as a transition region or transducer between a guided wave wireline and a free space which is wireless. Generally, the fields of antenna are divided into two regions. One is near field, second one is far field. In coming video, I will explain the radiation pattern, which I will explain half power beamwidth, that is HPBW, and BWFN, that is beamwidth between fresnels. What are the side lobes and what are the main lobes of radiation pattern. Then see you in the next video.